Yeah, let me introduce myself. I'm George Hendry. I'm a professor here at the School of Earth and Environmental Sciences. This is my fifth year in teaching. I was for 27 years at Brookhaven National Laboratory doing research. And my training is in civil engineering and ecology. So my whole career has been bringing experimental methods to ecologists, building apparatus, building large-scale experiments, things that ecologists typically haven't thought about doing because of the scale of what we wanted to do. I worked for about 10 years on acid rain research, and I was at the Norwegian Institute for Water Research in Oslo when acid rain just became a hot topic in the 70s. I came over here and worked with Gene Likens and Cornell and at the Hubbard Brook Experimental Station, and then I was offered Brookhaven. Went to Brookhaven, and I began to get more interested in this issue of climate change. And training in ecology includes a lot of plant science, plant physiology, and other topics. And so the community of people interested in that topic wanted to know how increasing CO2 in the atmosphere would affect plants and how those effects would ripple through ecosystems and what the exchange of material between the atmosphere and the biosphere might mean for the global balance of carbon dioxide in the atmosphere. Could we look to the terrestrial environment as a great sink to soak up all that CO2 and have the photosynthesis, plant soaking stuff? So I worked on that for quite a long time and built large-scale experiments out in the field where we could actually expose plots that were hundreds of meters in size with hundreds of individual full-grown trees in them to elevated carbon dioxide. And we built those kinds of experiments in the forest, in the desert, for a variety of different crops. And was very engaged with my blinders on in trying to understand that particular dynamic of the exchange of CO2 with the ecosystem, the ecosystem's response, and how that fed back onto that exchange process. So it just, as time went on, I became influenced by James Lovelock. How many of you know who James Lovelock is? He's one of the developers of the Gaia theory, which we now call the Gaia hypothesis of the Gaia theory. That the Earth tends to self-regulate, and that it's life on Earth that does that self-regulation, and that the Earth is habitable because of life processes. So I began to study more on Earth geohistory and the geocarbon cycle, carbon cycles through the whole, through the atmosphere, the biosphere, through the terrestrial environment. And most of the carbon on the planet is tied up in rock, and it got there because of biological processes. And it recycles over geological time, 100 million year times. But life is the key factor that governs the temperature of our planet. The carbon dioxide in the atmosphere is the regulating vernier on temperature. And life regulates the CO2. Well, we're part of life, and now we're doing something about regulating CO2. We're taking it out of geological storage and putting it into the atmosphere. The geological storage we call fossil fuels. And we're putting vast quantities of this into the atmosphere. Much bigger, hundreds of times bigger, 1,000 times bigger than the natural system is. Now, my friends, so I was giving some talks here at Queen's, and kind of a long story, but suffice to say they made me another offer that was very nice, and so here I am, and I'm a professor at Queen's, and I got, partly because I wanted to be engaged in teaching and getting young people who are going to have to actually live with the problems that my generation and previous generations created. I wanted to get them interested in this topic so they begin to do something about it. Here's this metaphorical Gaia breathing life into the earth. Lovely picture, I really like it. And what we're doing is poisoning Gaia. We're, you know, if you put a bag over your head, tight it tight and breathe, you live for a while, and then you die because you suffocate on all the CO2, no oxygen. So we're essentially suffocating Gaia by releasing all this CO2 into the atmosphere. So I'm with the School of Earth and Environmental Sciences. I'm also with the CUNY Institute for Sustainable Cities. This is an institute of the City University of New York that encompasses all the campuses, including Queens and Hunter and all the schools. So the institute represents the entire system. And we're very interested in a number of different topic areas, and one of the things I've been doing with the institute is trying to help them organize their research into different topic areas. Can you actually see the board? Because we could move down maybe, and then I'll leave that up to you. So what I want to talk to you today are these topic areas. And the overall topic is getting the idea of sustainability into the classroom, which is what I'm very interested in doing. And I think that the main part of it is really motivation. It's not so much what I teach in a particular course or my colleagues teach in particular courses, although that's critically important. But it's the motivation to get people interested in having a career dedicated to trying to do something about these problems. So here are the main topics. Climate change will govern sustainability. It's going to be the driving political, military, social, survivability issue of the 21st century. And I'll show you a little bit about that. I'm not going to make this a climate change program. And the fact that finally we recognize the reality of climate change. The main feature of climate change relevant to our region are in fact the actual warming of climate, the increase in sea level, and also ecological changes that are going on in the biosphere right now. I'll review the regional climate predictions that have been made. Now, predictions are a funny business. Predictions are always given a range. That's because we're never really sure about how the mechanisms all interact with each other, if you can imagine. There's this idea that the beat of a butterfly wings will cause a tornado 2 months out in Kansas. That's those of you that are familiar with this topic area know what I mean. But essentially, our future